First, a quick review about slopes and distances. So two lines are parallel if they have the same slope. Two lines form a right angle if they have perpendicular slopes. And just as a reminder, perpendicular slopes are opposite reciprocals. So for example, if you had a slope of 1/3, the opposite reciprocal of that would be -3/1 or just -3. Two sides are equal length if they have the same distance. And the key here is the word distance, because you would have to use the distance formula to decide if two sides have an equal length. These are the steps that you'll need to follow when you're trying to classify quadrilaterals on the coordinate plane. The first thing you want to do is graph the quadrilateral. This doesn't have to be anything fancy, just a rough sketch so that you can get an idea of what you're looking for, or if any of your answers are way off. The second thing you're going to do is find the distance for all four sides. So you're going to be using the distance formula. This will tell you which sides are equal. Third, you want to find the slopes for all four sides. This will tell you if you have any sides that are parallel, or if there are any perpendicular slopes or right angles. So I'm going to put right angles, and then in parentheses I'll put perpendicular, because that's when you have perpendicular lines, that's when you have right angles. And then there's this flow chart, which is actually really tiny because I had to fit it on the slide. But if you're having trouble when you're actually deciding whether it's a square, rhombus, kite, rectangle, or all the other quadrilaterals, this is kind of a flow chart that will help guide you to the right answer. So the first thing it tells you right here at the start is to calculate the distances, and then depending on what your answers look like, it guides you. So for example, if all four sides are the same, you would follow the arrow that says all four sides are the same. So then it tells you, okay, now calculate the slope. Once you calculate the slopes, one of two things is going to happen. Either the slopes will be perpendicular to each other, or they will not be perpendicular to each other. So let's say they're not perpendicular to each other, then you know that your answer is a rhombus. So it guides you through all the steps that you need to see in order to determine which quadrilateral you're looking at. We want to determine the best description for this quadrilateral ABCD, and we're going to prove using both the slope and distance formula. So the very first thing we need to do is a sketch, and I've actually put a graph on here because I'm not very good at drawing or straight lines or anything artistic. So I'm going to plot my points. So I want point A is at -2, 6. So I'm going to go left 2 and then up 6, and I'm going to label A. Point B is at 2, 7. C is at 1, 3. And finally D is at -3, 2. And then I'm going to connect the dots. So you can kind of see what your shape looks like. It looks to me like a rhombus. So as I'm going through and figuring out all my side lengths, figuring out all my slopes, I'm keeping in the back of my mind that I think this is maybe a rhombus. So that gives me some clues as to what I'm looking for. So next thing I want to do is write out all my side names. And I would do this by looking at your sketch and not by looking at the points, because sometimes the points may not be in the correct order. So the first side is AB, and then I have BC, CD, and DA. Okay, so the next thing I need to do is figure out all my side lengths, and this is going to be using the distance formula. So I'm going to write the distance formula up here because I want to show you a small shortcut when we get to the second step. Okay, so I'm plugging all of these things in, And I don't need to do anything with factor trees or simplification because all I'm looking for is, are they the same or not? So it doesn't matter if it's simplified, just whatever we get will be fine. So if I'm doing my slope for AB, I'm going to do 2 minus negative 2, and then 7 minus 6. And that would give me a total of the square root of 17. Now I have to use B and C. All right, so I'm going to do 1 minus 2 and 3 minus 7. And when you put this into your calculator, again, just the part that's under the radical, not the radical itself, you get 17. So I have another square root of 17. All right, now we're going to do the same thing for CD. So now I would have negative 3 minus 1 and 2 minus 3. And again, I get 17 under my radical. And then last but not least, DA. So I would have negative 3 minus negative 2 and 2 minus 6. And again, we get the square root of 17. All right, so I said at the beginning I thought it looked like a rhombus. And so far things are checking out because a rhombus has 4 equal sides. So things are looking good. All right, now my last step is I have to find the slopes. I'm going to write the slope formula up here. Okay, so there's a slight shortcut that you can do. It won't save you a ton of time, but it saves you a little bit of thinking. When you're finding the slopes, you'll notice that the, let's use yellow. This first set of parentheses here is the same as the denominator of the slope formula. And then the second set of parentheses is the same as the numerator. So once you've written out your distance formula, you can kind of just, it's almost like you're copying and pasting into your slope formula. So the slope here, for the first one, I would take the second set of parentheses, which is 7 minus 6, over the first set of parentheses, which is 2 minus negative 2. 7 minus 6 is 1, and then this actually turns into 2 plus 2, which is 4. So my first slope is 1/4. Now I have to do this 3 more times. All right, so I'm going to have 3 minus 7 over 1 minus 2, which is negative 4 over negative 1, or just 4. 2 minus 3 over negative 3 minus 1 gives you negative 1 over negative 4, which comes out to be positive 1/4. And then last but not least, 2 minus 6 over negative 3 minus negative 2. That gives me negative 4 over negative 1, or positive 4. All right, so if you look at my slopes, they are reciprocals, but they are not opposites. So that means that these slopes are not perpendicular to each other. If they're not perpendicular to each other, it means that they are not right angles. And since I don't have right angles, that means this is a rhombus and not a square. So my final answer, this is a rhombus because it has 4 equal sides and my adjacent sides are not perpendicular. Okay, same type of problem. We're going to plot our points, figure out what our shape looks like. So point E is at negative 3, 3. F is at 1, 5. G is at 4, negative 1. And H is at 1, negative 5. Okay, so here's my shape. It looks not exactly like a rectangle. I don't know. So let's do our side lengths. And again, I'm taking my side lengths from the picture and not from the points. And on the next example, you'll see why that's actually very important. So there's my 4 sides. So now I have to do distances. All right, for side EF, I would have 1 minus negative 3 and 5 minus 3. And this comes out to be 20, square root of 20. All right, now I'm going to do side FG. So I would have 4 minus 1 and negative 1 minus 5. And this turns out to be 45 under the radical. Okay, side GH, I would have 1 minus 4 and negative 5 minus negative 1. This turns out to be 25 under the radical. And then the last side, HE, I would have 1 minus negative 3 and negative 5 minus 3. And this comes out to be the square root of 80. So you'll notice that I have no sides that are the same. So it can't be a rectangle, because a rectangle would have 2 pairs of equal sides. Same goes for parallelogram, so it can't be either of those. I know that it's not a square and a rhombus, because those would have 4 of equal sides. The only 2 left are trapezoid and kite. Kite also has 2 pairs of equal sides, but they're adjacent. But again, I don't have any equal sides, so it has to be a trapezoid, or it could be just a generic quadrilateral. So before we can declare that this is a trapezoid, we have to go a step further and do the slopes. If this is a trapezoid, it should have 1 pair of parallel sides. If it's just a generic quadrilateral, then the sides won't be parallel. So here we go. We can do the shortcut again, and this time I might even take it a step further, and we can actually simplify the numbers before we put them into the fraction. So 5 minus 3 is 2, 1 minus negative 3 is 4, so that reduces to 1/2. All right, my next slope, negative 1 minus 5 is negative 6, 4 minus 1 is 3, so this comes out to be negative 2. Negative 5 minus negative 1 is negative 4, and then 1 minus 4 is negative 3. So those negatives cancel out, and I have 4 over 3. And last but not least, negative 5 minus 3 is negative 8 over 1 plus 3, which is 4. So that's negative 2. So if you look here, I do have a pair of opposite sides that are parallel, and it actually comes out to be these two right here. So this is definitely a trapezoid. And the reason is because it has no equal sides, and we have 1 pair of parallel sides. All right, last one, and this one is tricky, and you'll see why when we plot these points here. So we're going to sketch. O is at 5, 5. L is at 0, 0. V is at 8, 4. E is at 7, 1. Okay, now the reason that this is tricky, if I connect the dots in the order that they're listed, so that would mean I would connect O to L, so those two would get connected. Then I connected L to V, and then V to E. You can see that this does not make a quadrilateral. So we have to take the points we were given and connect them in such a way that we actually make a quadrilateral. So I'm going to erase what I have here and start over. So I'm going to plot my points again. So here's O, L, V, and E. Okay, so if I connect them like this, that's going to give me the shape that I want. That makes a quadrilateral. So to me it looks like a kite. if that's true, then what's going to happen is we're going to get two pairs of equal sides, but the sides will be next to each other instead of opposite from each other. So the side names, I'm going to start with L. So I would have LO, OV, VE, and EL. Now, if you did not draw the picture and you just listed out the sides based on what the points looked like, your sides would be OL, LV, VE, and EO. And if you compare these points right here to the ones that I wrote down, you'll see that they're different. Some of them are different. So you're going to get the wrong answer because you're not finding the right distances. So that's why drawing the picture is very important. All right, so now let's do side lengths. So LO, I would have 0 minus 5 and 0 minus 5. When you put that in your calculator, you'll get 50 under the radical. Now we're going to do OV. So I have to use the first and the third points. So be careful that you're using the right points. So I would have 8 minus 5 and 4 minus 5. And this comes out to be the square root of 10. For VE, I would have 7 minus 8 and 1 minus 4. And this also comes out to be the square root of 10. And then EL, so that one would be 7 minus 0 and 1 minus 0. And this also comes out to be the square root of 50. So now if we look here, OV and VE are here, square root of 10, square root of 10. And then LO is the square root of 50 and EL is the square root of 50. So you see that I do have two pairs of equal sides and that they are adjacent to each other. So this is definitely a kite. Now I can say this is a kite without doing anything with slopes, because if you go back to the notes for 2.6 and you look at the properties of a kite, you'll notice that we didn't say anything about the opposite sides or the adjacent sides. So this is the only one where if you get that it's a kite, you do not have to do your slopes. So I'm going to write over here, we don't have to do slope because we know it's a kite. And we know that kites don't have rules for slope. So we don't have to do slope because we know kites don't have rules for slope. So that's pretty exciting. So it's a kite because it has two pairs of equal adjacent sides.